Okay, so we're going to do the second lesson of acids, bases, and solutions. So today we're going to talk about what molarity is, calculate molarity, and then I'm going to show you how to make a solution. If you'll recall what we did in the last lesson, we just talked about what concentration is, especially in this class. It's the measure of the amount of solute, so like the salt, that is dissolved in a quantity of solvent, which is the liquid. So basically, if we were dissolving salt with water, this would be the salt and this would be the water. Our unit, our as in chemist, unit of concentration is molarity. And basically, molarity is the number of moles, you know what that is, of solute, so that the powder, dissolved in 1 liter of solution. And remember, this is not solvent, okay? So that's one tricky question that you'll see maybe on the test or on the quiz, I don't know. So make sure you don't get trolled by that. So molarity is moles of solute over liters of solution. The equations are quite simple. It's just a division. And then obviously I won't always ask you for molarity. I might ask you for moles of solute. And you will have molarity in liters or maybe milliliters or maybe here, not here, but maybe I'll ask you for liters. And maybe I'll give you grams and you'll have to convert to moles of that solute. So obviously you're not always just finding the molarity on your test. You might be having to do a couple more steps. All right, so like I said in the last slide, the volume is the total volume of the resulting solution, not just the solvent, okay, not just the water. It would be how much the water plus that solvent is. All right, so how to make a solution. So you've seen these flasks right here, okay? This is called a volumetric flask, and you'll notice that it has no tick marks on the side. That's because the only tick mark we care about is right here. So we have multiple different kinds of these, and I'll actually show you whenever I do a homework practice problem because I don't really want to have like a little tiny screen right here just to show you the flasks. But anyways, let's say we're trying to dissolve this solute in here, okay, and this is the solvent, this is water. So this is a 1 liter volumetric flask. So that means right here at this line, that means it's going to be a whole liter of the solution, which means this and this mixed together. So to make a 0.5 molar, when you see this unit here, it means molar. That's not moles. Moles is a lowercase m. Solution. So you would add 0.5 moles of solute. So you have half a mole of this, and you would add it here, okay? And then you would fill some of the flask with water, and then you would swirl it around, okay? So basically you poured all the powder in here and poured a little bit of water and kind of shook it up. And then you would fill the flask up to that tick mark. Remember, we saw it in this last slide right here. We're actually zooming in, and you would fill the water up all the way to this line. And then you would have a 0.5 molar solution in a 1 liter volumetric flask. All right, so that we're going to do kind of in person and in a lab. You're going to make your own solutions. And I'm really thinking about having you do a quiz with that because that's so critical in any science class you go to. It's actually kind of sad if you plan on going to IB and you don't know how to make this because this is just a simple calculation. Okay, so doing the calculations, again, it's just M equals, or molarity equals the moles over volume. So literally, what is the molarity of a solution that contains 0.25 moles of NaCl in 0.75 liters of solution? So our molarity, that's what we're trying to find out, okay? And then our moles is 0.25 moles. Sometimes you'll be given grams and you just need to convert that into moles, okay? And you guys have been doing that since quarter 2. Liters, here you're given liters, so watch out to make sure that it's not milliliters because then you got to move the decimal over 3, okay, to the left. Or if you're given, I don't know, kiloliters or something weird, okay, make sure you know those conversions. So anyways, you just take your molarity, that's what we're trying to find, and it's moles over liters, okay? And you just do the calculation and you've got your answer. So Molarity is simply moles over liters, so this unit and this unit, it's the same. I would accept either or. All right, so here's more of a little more of a complicated, I wouldn't say complicated, but it's not, simple. You have to do a little bit of algebra. But what volume of a 1.08 molar potassium iodide solution, okay, so that's our 1.08 molar solution, would contain 0.642 moles of potassium iodide. So we have molarity and we have moles. We just need to find out the volume, okay? So we plug in our answers, okay, or whatever, our variables, and then we need to do simple algebra. So you would multiply liters on both sides, and then divide this, or just switch, whatever, and then you would have your answer. How many grams of calcium bromide are dissolved in 0.455 liters of a 0.39 molar calcium bromide solution? So basically we're looking for grams, okay? Unfortunately, our equation is going to give us moles. And then we just simply convert moles to grams using dimensional analysis, and that's just a one-step problem. Okay, you just have to grab the mass of calcium bromide off the periodic table. So molarity we actually have, it's the 0.39. Moles is what we're trying to find, and then the liters is in liters, so 0.455 liters, okay? And then we just plug in all of our answers, or our variables. I can't speak today. So we have molarity here, okay, and then you're going to divide moles up here, which is what we're trying to find. Don't let this right here, the fact that it's in grams, confuse you and put grams and you think that's the answer, okay? It still has to be moles here, and you must convert moles to grams later. So once you get your answer, simple algebra, you would have to manipulate this equation to get moles by itself, which would just be switching these two. So you have moles. So then you have to do a quick dimensional analysis problem. So you have moles. You have to find out how much calcium bromide weighs on the periodic table. And then 1 mole will go down here, and then the mass of, did I say potassium? I meant calcium bromide if I said potassium. And then here's us doing the addition. So on the periodic table, calcium weighs this much, bromide or bromine weighs this much, and we have 2 of them. And then we will have our answer in grams.
So we're going to do the last 2 homework problems. Usually those are the ones you guys want me to do, so we're going to do it. Alright, so how many milliliters of a 0.63 molar solution would contain 12 grams of aluminum nitrate? Alright, so of course we have milliliters here, not liters. So let's write our knowns and unknowns. We have moles, molarity, moles, and volume, which is in liters. So we have a 0.63 molar solution. Oh my gosh. There we go. And then we have, we don't know how many moles, do we? Yeah, we have 12 grams of AlNO3. So obviously this is not moles, so we need to just simply convert it. So we're going to do a conversion. This is grams, so we'll have grams of AlNO3 over 1 mole, and then we will have our mole solution. So we have, we have to find out how much it all weighs. So aluminum on the periodic table, where is it? It weighs 27-ish. 27 grams, and we only have 1 of them, so we just add nitrogen. We have 3 nitrogens, and nitrogen weighs 14 grams, and we have 3 of them. And then oxygen, we have 3 times 3, which is 9. I see a lot of kids who will put 6 here, and that's kind of what gets them a lot of points off, so make sure you're paying attention. 3 times 3, not 3 plus 3. So oxygen is about 16 grams, and there's 9 of them, okay? So then we will add them all together. So that is 27, this pen is annoying, 27, and then 14 times 3 is 42. You guys have stolen all of my calculators, so I do not have a calculator anymore. 16 times 9, 144. And then you add them all together. So we have 144 plus 43 plus 27, and we have 214. Okay, so here we'll go 214 grams. Okay, so now we just do 12 divided by 214, and we will have our moles. 12 divided by 214. 0.56 moles. So 0.56 moles of this substance, and it has 2 significant figures, and so does this, so we're happy. All right, liters, that's how money we're having to find. So basically we have 0.63 molar equals to 0.56 moles divided by volume. So we want to get volume by itself. Divided by 0.63. Most of you can just know that these two will switch places in this case, but I'm kind of showing you my thought process. So basically you have liters equals this divided by this equals 0.56 divided by 0.63. So liters, we have 0.88, and then this is 9, so it'll actually be 0.89 liters. But we actually want milliliters, like the question said. So you can do dimensional analysis to do this. You would know that liters here, you would put 1 liter down here and 1,000 milliliters here, or you can just move the decimal over 3. So then you would have 890 milliliters as your answer. All right, moving on, we have another one where we have mass involved, which is probably a good thing that we are going over this together so you don't get trolled. So we not only have mass, but we have milliliters again. And a big chemical. So basically we have molarity, we have moles, and we have liters. So molarity, we have 0.35 molar, okay? Moles, we have, that's what we're trying to find, okay? We're actually going to find moles, and then we'll have to convert it to mass. And then liters, we have milliliters. So liters, we have 1, 2, 3. So liters, we actually have 1.575 liters, okay? You could have used dimensional analysis and did milliliters here and then milliliters down here, and you would be dividing by 1,000. But moving the decimal over, especially in the case of just converting between the same units like that, this is much more easy. All right, so now we have the equation. So we have M equals moles over liters. So we have 0.35 molar is equal to moles over 1.575 liters. So now we have this as our variable. So if we just multiply 1.575 liters on both sides, 1.575, okay, then we will have moles by themselves, okay, and that'd be 1.575 times 0.35, okay. Let me get my calculator. Okay, so 1.575 times 0.35, that is 0.55 moles, okay? So we have 0.55 moles of Ba3PO4, 2. Can you see? Okay, so we have that many moles of it, and then we need to just convert to grams, so that means we will have grams of it here. Okay, and then we need to cancel it out with 1 mole of it. So for every 1 mole of barium phosphate, we need to find out how much that weighs. All right, and to find out how much that weighs, let's just kind of go up here where we have space. So barium on the periodic table weighs 137-ish, 137. And then, oops, there's 3 of them. That's why I typed it in. All right, so barium weighs 137 times 3, and that is actually 411. All right, where are we now? So we have phosphorus. There's 2 of them. Phosphorus weighs 31-ish, 31 times 2, which is 62. Then we have oxygen, which we have 4 times 2, which is 8. Oxygen weighs 16. So 16 times 2 is, and by 2 I am wrong. 16 times, how much was it? 8. Okay, 128. Let me just add them all together. 411 plus 62 plus 128. And that is 601. Okay, so we will put 601 grams here. That's the molar mass of barium phosphate. Now we just take 0.55 times 601. Okay, and that's our answer. We have 330.55 grams, but we only have 2 significant figures here, so we only need 2 here. So we're just going to put 330 grams of barium phosphate.